Okay, I'm going to go over some highlights from your Unit 3B review to make sure that you're ready for your test. On this first section here, you are just practicing your division. Remember that on your test, nothing will specifically tell you have to divide it, but it is good practice to make sure that you know how to, because it will come up a lot throughout the rest of the packet. In this next section, it's telling you specifically to use the remainder theorem to evaluate the function at that given point. So you must synthetically divide in whatever number is in the parentheses, and then remember that your remainder is whatever number you get after you synthetically divide it in. So if I fill this in, make sure you're missing your constant, so you need a 0. Whatever number you get over here as your answer is the value is the same as if you had plugged that 3 into the function. So that number right there will be your answer after you finish with your synthetic division. To determine if it is a 0 of a function, your remainder must be 0. So if this number over here at the end is a 0, then it is a function, or a 0 of the function, and if it's not, then it's not. But you must use synthetic division on this section, and you will have to on the test in order to get the points for that problem. On this next section, this is where you will actually go through and find all of your zeros using your rational root theorem and your remainder theorem and your factor theorem in conjunction with each other. To list all your possible zeros, you're going to go through and list out the factors of your last term. So in this case, the factors of 4 are 1, 2, and 4. And then on the denominator are the factors of the first term, are your 2. Remember that I am okay if you leave it like this as long as you know what that means, but if you need to write it out, make sure you do that. So we would, for example, take every numerator and put it over each denominator. So we would put them over 1, so it's plus or minus 1, plus or minus 2, plus or minus 4. And then I would put each of my numerators over the 2, so plus or minus 1/2, plus or minus 2 over 2, which is really just 1, so I don't need to write it again, and plus or minus 4 over 2, which is also just 1. So these would be my 8 options for what to divide into my problem. Then you need to go through and guess and check until you find something that does work. Remember, I recommend, what I typically do is I synthetically divide it in, but you can also just evaluate it, because remember, like we talked about in the last section, your remainder and evaluating it will be the same. Your goal here is that your remainder is 0. So if I'm guessing and checking, I'm going to plug a 1 in, bring down the 2. 2 times 1 is 2. This gives me 17. 1 times 17 is 17. This gives me a 1. This gives me a remainder of 5, so that means this one doesn't work. So I'm going to go through and just erase the work and try a different number in the parentheses, and you just keep going until you find one that works. This is going to be 13, so negative 13. That's not going to work. You try again. Sometimes this takes a while, but you just got to keep trying. Try 2. This is 4. Gives me 19. That's going to get too big. Try negative 2. This gives me positive 11. Negative 22. Again, that's going to get too big. And sometimes you do just have to keep trying. Try a half. Half of 2 is 1. That gives me 16. Half of 16 is 8. That gives me negative 8. Half of 8 is negative 4. And this one does work. Remember, if you divide in a fraction, so the fact that this had into 1/2, I need to divide all these numbers by 2 also. So this is going to be x squared plus 8x minus 4. This 1/2 would have been a 2x minus 1 if it had been in a factor. It's very important that you don't lose this, because this will be a part of your answer. Once you get to this point, you're going to have to try to solve the resulting polynomial. You might factor, you might quadratic formula, whatever it is. You will need to keep your answers exact on this part, so make sure if you quadratic formula that you do simplify your radical fully and simplify your fraction fully. On this, I cannot multiply negative 4 and add to 8, so I will need to quadratic formula. So I will remind you of how to do that. We do negative b plus or minus the square root of b squared is 64 minus 4 times 1 times negative 4 all over 2a. In the parentheses, this really becomes 64 plus 16, which is going to give you an 80. So negative 8 plus or minus the square root of 80 over 2. And then you do need to simplify that radical. So a 16 goes into 80. 80 is 16 times 5. When you simplify that, that gives you 4 root 5. So my problem is now negative 8 plus or minus 4 root 5. And each of those are over 2. And when you simplify that, 8 divided by 2 gives you a negative 4. Plus or minus 4 divided by 2 is 2 root 5. So that gives me 2 of my answers. My third answer is the 1/2 from originally. And so those will be the 3 answers here. So my answers are going to be 1/2 and then negative 4 plus or minus 2 root 5. Remember, on this section, I want you to keep it exact. You may be able to factor once you get through that. You might not, and it's going to have to be something you kind of play by ear. On this next section, you have graphs. Mine got cut off or switched to the next page on accident. You're going to go through the characteristics and make sure that you tell me or show me a sketch of the graph. Remember that your first two here, at least, the degree and the leading coefficient tells you what it looks like, whether they're both going up, one going down, whatever it may be. And then your roots will talk about your x-intercepts. Your multiplicity tells you whether it touches or crosses. An even multiplicity like this one will turn around at that point on the x-axis, whereas an odd multiplicity will go through at that point. So you will sketch these. On the answer key, I have a description of what it should look like. So look at that and make sure that you know where those came from, and if you have questions, let me know. Okay, the next big part of this, as you can see, multiple pages. Again, yours printed correctly. When I turned this into a PDF, it did not. The next multiple pages are all about graphing, and I just gave you plenty of graphing examples that you could go through and see what you need to do. And your original process is very similar to what we did over here on number 7, as well as what you're going to think through on 10, 11, and 12. And then you're just really putting it all together. So I'll talk through one of these, but remember that all of them work very differently, and so you're going to have to go through case by case and problem by problem. When you're doing these, the first things we talked about finding out in class was your end behavior. And remember, that's looking at your first term and whether its degree is even or odd. So this 4 is even. And whether the number itself is positive or negative. So this one's even and positive. So it will go up in both directions. Okay, that means we can fill that in on our limits immediately because both sides will go up. So to the left it goes up and to the right it goes up. For your x-intercepts, you have a lot of ways to do this, and you have to process through on each problem and see. Remember, the first thing I would always try to do is factor. So we always take our equation and set it equal to 0 and try to solve it. Again, I would always try to factor first. So in this example, I can pull out an x squared, and it's already factored for me. Okay, now it means that I will not have to rational root because I have this down to a quadratic. Okay, I'm going to try to factor what's resulting in there. So multiplying a -3, adding to -1. That is impossible. So that means for this section, I'm going to have to quadratic formula. It might factor, you might not have to quadratic formula. It depends on the problem. And so we have to quadratic formula this one. So I'll fill it in all over 2 times 1. But the nice thing, on the part where you are graphing, you get to give me this as a decimal. Okay, when you are graphing, I don't need the whole exact value. You don't have to worry about simplifying. So here, this would be what I get from the quadratic formula, and then I'm going to type this in my calculator and get those two numbers. So I'm going to do 1 plus the square root of 13, and then divide that number by 2, and I get about 2.3. 1 minus the square root of 13, divide that by 2, and you get -1.3. So those are going to be my two x-intercepts. So 2.3, again, you're just going to approximate, and -1.3. Okay, then we did go through and find our y-intercept, and I left it off here because it won't specifically ask it for it on the test, but it is helpful to give you another point. For your y-intercept, you're going to plug in 0. In this case, it's going to be 0 minus 0 minus 0, so it's going to be at 0. So I know I have another point right there. Oops, and sorry. That other x-intercept we should have labeled before. I accidentally lost it. This is what I remind you regularly not to forget. I forgot that I had this x squared right here, which gives me an x value of 0 molt 2. This is why it's super important to pull that through with you so that you don't accidentally lose an answer. So that x squared gives me another x-intercept that I needed to list. And finding my y-intercept saved me and made sure that I found that, so it is extremely important. For your relative extrema, in Algebra 2, I give you your increasing and decreasing intervals, and so you need to take these numbers and plug them into your function. So negative 0.9 we're going to plug in, we're going to plug in 0, and we're going to plug in 1.7. I already know that if I plug in 0, I'll get out 0, because I already did that over here, so I'm not going to do it twice. But if I plug this in, and I'll do this real quick, please be careful while you're plugging it in, because I don't want you to get it wrong on the test while you're typing it in. So use your parentheses appropriately and all of those things. So when I plug this in, plugging in negative 0.9 first, out of my calculator I get negative 1.04. So when I graph it, I'm really going to graph it as about negative 1. That's fine. And then I'm going to plug in 1.7. So do plug in both of them. And I get a negative about 5.2. Okay, just as a note, if any of you are in Honors Algebra 2, remember to find this, I do not give you your increasing, decreasing. This is where you would have to do your power rule, solve that equation, and then plug these in. You'll still get the same values though. Okay, and then I'm going to graph these. So at negative 0.9, I'm at negative 1, so I'm about there. And at 1.7, I'm at negative 5.2. And again, just do the best of your ability to get it there. Okay, then I get to go through and play connect the dots. So I had to start up, cross at your x-intercept, turn at your turning point. 0 was molt 2, so it didn't go through. This is approximately what my graph looks like. Then to go ahead and fill in the chart. My domain on all polynomials is negative infinity to infinity. Range is bottom to top, so this low value right here is really down at negative 5.2. So it goes from negative 5.2 to infinity. And now I can more easily fill in my maximum and minimums. This negative 0.9, comma negative 1 was a minimum, and so was the 1.7, negative 5.2. The only maximum in this problem is over here at 0, 0. Okay? While these are a lot of work, make sure you're going through slowly, label your work just like I've done so that it's more easy for you to find what's happening and organize your way through the process. Okay, so you do have multiple examples here of plenty of these and how they work out. Remember to always try to factor first, but if you can't, like here on number 16, you can't factor that, you're going to have to rational root. Okay, so go through and see what you can. I've given you a mixture of ones you can factor, ones you can't. I would focus on what you need to practice on and make sure you hit those ones that look like that. 20 and 21 here are helping you practice to find your equation like you'll have to do on ones like 22 and 23. So I'll pick one of those to talk about. Okay, here on 22, you're going to write the equation. And so we need to figure out our x-intercept. So I have an x-intercept here at negative 1, 0 and at 3, 0. The negative 1, 0 is a molt 2 because it turns around. So I'm going to write those as factors. It's going to be x plus 1 and x plus 1. And then the 3 gives me x minus 3. Then you have to go through and FOIL this all the way out. Once you have also considered if it's positive or negative, this one is positive, and it is odd. Okay, the odd helps you to check you have the right number of parentheses. Since it was odd, I should have 3 factors, and I do. It's positive because it goes up to the right, and so I'm not going to put a negative in front. When I FOIL this, I'm going to have x squared plus 2x plus 1 for this first 2 binomials multiplied together. Be very careful as you multiply through the rest of it. This is the part sometimes we mess up on. Make sure you do each term in your first trinomial by that whole binomial. So I'm going to do x squared times x is x cubed. X squared times negative 3 is negative 3x squared. Then I'm going to do 2x times everything back there. So plus 2x squared minus 6x, and then the 1 plus x minus 3, and then you combine your like terms. So my equation here would be x cubed minus x squared minus 5x minus 3. Okay, then you'll go through and fill in the characteristics just like we did on the last one. The last thing you have to do here is go ahead and try some of the word problems, and I have two different examples here for you. The biggest thing you have to remember, I always suggest that you sketch the graph first. This doesn't have to be perfect, but you do need to think about your end behavior, find your x-intercepts. I'm giving you your increasing, decreasing intervals to find your relative extrema, so plug those in and plot it. And make sure that you know what it looks like, because then when you go through and answer the questions, you're figuring out whether you care about the x-intercepts or a relative extrema. So for example, when it has the largest population, this would be a maximum value, so you want to look at your graph and figure out what that was. A net growth of 0 would be an x-intercept. Okay, so sketch the graph first. Once you've done that, go through and figure out what you really want to know about and tell me those relating answers.